Like I've said before, these first few lessons are all about getting us to the point where we can find trig ratios of any angle in degrees or radians, and we can solve trig equations involving any angle in degrees and radians. And some of the trig ratios, well, obviously, I mean, to find any trig ratio, you could use your calculator, okay? I mean, if I said, find the tan of 50 degrees, that's finding a trig ratio, you would just punch it into your calculator, okay? But a lot of these trig ratios, we're going to find without using a calculator. We are going to find exact values for them, okay? So the last thing we sort of need to do to prep for all of this is the unit circle, okay? And the unit circle is going to allow us to find exact trig ratios and solve certain equations where we can get exact answers for angles. Well, what is this unit circle? It's a circle that we place on a coordinate grid where the radius is 1 and the center is at the origin, 0, 0. So here's a circle. The center is at the origin, and the radius from the center to any point on the circle, that's 1. That's why we call it unit. Unit means 1. Okay. Now, what we need to do to help us do trig ratios and trig equations is we need to find points on the unit circle. I need to figure out, is a point on the unit circle? And if it is, I can use it to do some trig. Okay. So here's a point. I don't know what it is. So I'm going to call it XY. Well, I know that the radius is 1, so what I'm going to do is I'm going to make a right triangle using the radius 1, using the positive x-axis, and then drawing a vertical segment here. Because this is the point XY, this length has to be x. Like if this was the point 4, 3, this would have to be 4, because I count 4 across. If this was 3, this would have to be 3, so it's whatever the y value is. And with that, okay, because we've got a right triangle and we're dealing with sides, we can use the Pythagorean theorem, a squared plus b squared equals c squared. But instead of a, I'm going to do x squared. Plus, instead of b, I'm going to do y squared. And the hypotenuse, well, we know that it's the same as the radius of a unit circle, which is 1 squared, which is 1. This is the equation of the unit circle. This helps me determine if a point is on the unit circle. So if I give you a point, you can tell me whether it's on the unit circle by going this squared plus this squared, does it equal 1? So like if I said the point 1, 2, is that on the unit circle? No, because if we did 1 squared plus 2 squared, we get 5. That's not 1. Or sorry, we get, yeah. We get 5 squared, still no. How about this point? Is this point on the unit circle? Well, we have to check it out. This is the x coordinate, this is the y coordinate. Remember the equation for the unit circle. Does the x coordinate squared plus the y coordinate squared equal 1? Well, I got to figure out the left side. If it does, this point is somewhere on the unit circle. If it doesn't, it's not. So what's root 3 over 2 squared? 3 over 4. What's 1/2 squared? 1 over 4. Does 3 over 4 plus 1 over 4 equal 1? Sure does. So it's on the unit circle. So it's pretty straightforward to test whether a point's on the unit circle or not. A little variation on this problem. What if we are given the point, but we are not given the y coordinate, but we're told it is on the unit circle? How could I make an equation to figure out what y is? Sorry? Start again, sorry. Negative 3 over 5, once again, the parentheses squared, plus y squared has to equal 1 because it's on the unit circle. So now it's a quadratic equation because we're solving for y squared. We don't have to factor this one. We can just get everything to one side and solve from there. So what's negative 3 over 5 all squared? Not negative. 9 over 25 plus y squared. Well, how do I write, in order for me to subtract 9 over 25 from both sides, how do I write this as a fraction over 25? Right. So to get y squared by itself, take away 9 over 25 from both sides, and I get y squared is equal to 16 over 25. Who's going to get this right?
Plus minus square.
Well, nice. Y equals plus minus the square root, which equals positive or negative 4 over 5. And that makes sense because this is our unit circle. And if we've got the point negative 3 over 5, which is going to be somewhere here, if this is negative 3 over 5, I could draw a right triangle like this, or I could draw a right triangle like this. Because this point is negative 3 over 5, comma, the y value I found, 4 over 5. But I can have a second point on the unit circle where the x value is negative 3 over 5. And that's when y is negative 4 over 5. So it makes sense that there's two answers. Okay. So be familiar with a question like that. Okay, now we're going to go on and we're going to develop the unit circle. This is actually going to be a repeat from last year, what I'm about to do. Okay. Oh, getting excited next door. All right. What I need to do to figure out trig ratios of certain angles and to solve trig equations that involve certain angles is I need to put triangles in the unit circle. And if I need to put triangles in the unit circle, remember the unit circle has a radius of 1. So that means that the hypotenuse has to be 1. Okay? Here is a triangle. 45 is a very common angle we use. Okay? Here's how you would make a 45, 45, 90-degree triangle, and these would be correct measurements. Remember, 45 and 45, not only is it a right triangle, it's isosceles. Two sides are the same. So if I say this is 1, this must be 1, and then by Pythagoras, this must be square root of 2. Because 1 squared plus 1 squared is 2. 1 squared plus 1 squared is 2, and the square root of 2 is obviously root 2. Okay, so that triangle makes sense. Like I could draw any, don't write this down, but I could have done anything for 45, 45. I could have done 3, 3, and then 3 squared plus 3 squared gives me root 18 when I find the actual side. But I use 1 because it's an easy number to work with. But remember, I want a similar triangle where this is not root 2, it's 1. That's what I want in order to be able to slide it into the unit circle on a grid. How, and remember, this is proportional. What would I divide this hypotenuse by to get this? Divide square root 2. And if you're going to do that to one side, you got to do it to all of them. So how do I have to change this one? I've got to go 1 divide square root of 2. I got to go 1 divide square root of 2. But if you remember from our work with radicals last year, we never left square roots in the denominator. What do I multiply by so that the square root, or so that the denominator no longer has a square root? Square root 2. So this gives me square root 2 over positive 2. That's the actual side length I'm going to use. And obviously this is going to be the same thing. So in a right triangle, where one of the angles is 90, obviously, because it's right, and the other two are 45s. And if I want the hypotenuse to be 1, these two other sides must be root 2 over root 2. Okay. Other common angles that we use are 30 degrees and 60 degrees. Well, fortunately, we can make one right triangle that has both 30 and 60 in it, because 30 plus 60 plus 90 is 180. That's a right. That's a triangle. So what I'm going to do is I'm going to make a big triangle where each side is 2. So this is 2. This is 2. This is 2. But then I'm going to slice it in half. So if I slice this in half into 2, this is actually an equilateral triangle, because all sides are the same. But if I slice it in half, I create a right triangle where this is 30 and this is 60. This is still 2. This must be half of 2. And then by Pythagoras, I can figure out this. I get this by doing 2 squared minus 1 squared and taking the square root. So if we want to make a 30, 60, 90 triangle, the sides must be 1 for one of the legs, root 3 for the other leg, 2 for the hypotenuse. But I don't want that. I want the hypotenuse to be 1. Which means I have to make a similar triangle. What do I divide by? 2. Which means you got to divide everything else by 2. So what's root 3 divide 2? It's just root 3 over 2. What's 1 divide 2? Just 1/2. So when we have a right triangle where this is 30 degrees, this is 60 degrees, the sides must be root 3 over 2, 1/2, and 1. That's how I get these triangles. Okay, so I just explained how we get them. Now we're going to take these ones and we're going to slide it into the unit circle. So remember that 45, 45, 90 triangle. If we slide this in, and this is also 45 degrees, the one where we made the hypotenuse 1, what were the lengths of these sides again? Root 2 over 2. So what's a point, or sorry, what's a point on the unit circle when the angle coming out is 45 degrees? Root 2 over 2, comma, root 2 over 2. Okay, so a point at 45 degrees is root 2 over 2, comma, root 2 over 2. Right? Now I'm going to go back, take that 30, 60, 90, and slide it in like this, where the 30 degrees is coming out from the center. This was 1, remember? What were the other 2 sides? Which one is root 3 over 2? The longer one on the bottom. Which means this side is 1/2. So therefore, at 30 degrees, a point on the unit circle will be root 3 over 2, comma, 1/2. I'm going to take that 30, 60, 90 triangle again and stick it in like this, where the 60 degrees is coming out from the center instead of the 30. Remember, the hypotenuse, when I stick that unit circle in, or stick it into the unit circle, is 1. What's this side? Yeah, it's the longer side, root 3 over 2. So they've switched. And this is the shorter side, 1/2. So if the angle coming out of the center is 60 degrees, the point on the unit circle is going to be the reverse of 30 degrees. 1/2, comma, root 3 over 2. So we've already got 3 points on the unit circle. Okay, and again, this is review from last year. So just to summarize, and I'm going to leave the first one and the last one blank for a second. When it's 30 degrees, the point on the unit circle we saw from above is this. When it was 45 degrees, the point on the unit circle had the exact same 2 values, root 2 over 2. And when it was at 60 degrees, it was the reverse of 30. 1 over 2, comma, root 3 over 2. What's the point on the unit circle if the angle is 0 degrees? Here's the unit circle. Okay. Well, making a triangle with 0 degrees, it's just going to look like this, isn't it? It's just going to be, it's not even going to be a triangle, but it's going to hit here on the unit circle. What point is that? 1, 0. What about if I went all the way up to 90 degrees? Again, I'm not making a triangle, but it still hits the unit circle. 0, 1. This is what we discovered last year, except now you have to remember the equivalent radian measures. Well, how do you find the equivalent radian measures? Remember, times pi over 180. Don't worry, you're not going to be multiplying by pi over 180. You're going to remember these. Okay. Well, 0 is pretty easy. 0 times this is still 0 radians. $30 times 180, if I reduce, I get pi over 6. Or sometimes you'll hear it called pi by 6. If I multiply this by 180 and reduce it, I'm going to get pi over 4. If I multiply this by 180 and reduce it, I'm going to get pi over 3. And if I multiply this by pi over 180, I'm going to get pi over 2. 90 degrees is half a circle. Half a circle is pi. So 90 is a pi over 2. Okay. Any questions so far? All right, so we've covered the basic angles. Now, I always put this in, but I always skip it. We're going to take this. We're going to take these. And we're going to skip, and go here. Straight to here. Because we're going to put them on the unit circle. And I'm going to use different colors for different families, which I will explain in a second. Okay? So, when we do a triangle like this with 0 degrees, which was also 0 radians, okay? So notice there's a spot for you to write the degree measure of the angle and the corresponding radian measure of the angle. We saw that it hit the point on the unit circle 1, 0. When we went up to 90 degrees, which was what in radians? Pi over 2. We got 0, 1. When we did 30 degrees, which was how many radian? Pi over 6. What was the point we got? 3 over 2, comma 1/2. And we did 45 degrees. From how many radians? 5 over 4. We got the same two values, root 2 over 2 for both. And finally, We discovered 60 degrees, which is how many radians? Pi over 3. We got the reverse of 30 degrees for pi over 6. So we got 1/2 root 3 over 2. So I put these colors on them because they're going to represent different families. The first family, the purple one, they go up by 90 degrees. Because we're going to have, hello. Look at that. Why did I just erase that? Weird. Okay. Oh, I need to erase those too. What's the next group in 90 degree family after 90 degrees? Well, I add 90 degrees, so I go here. So what's this angle? Remember, we always start measuring from the positive x from here to here. 180. Which is how many radians? 1. And what's the point that it hits at the unit circle? -1, 0. Going from 180, if I add another 90, I get down to 270. Which is how many?
6 over 9.
6 over 9?
2 over 3. 2 over 3.
2 over 3?
5.
Well, let's look at this. This is 0. This is 0. This is 1 pi over 2, right?
Yeah.
Isn't pi the same as 2 pi over 2?
Yeah.
What do you think this one would be? 3 pi over 2.
That's what I said.
You said 2 over 3,
2 over 3.
which is
That's what I meant.
a completely,
2 over 3.
utterly
The same thing.
different number. What's the point that it hits on the unit circle? 0, -1. So that's the 90 degree family, or the pi over 2 family. The purple ones. There's one more, but we don't have to draw it, because what if we did a complete circle? Well, wouldn't we end up at 0 again? And a complete circle is 2 pi. So what's the point at 0 degrees or 0 radians and 360 degrees or 2 pi? The same point, 1, 0. Okay. The 30 degree family. The 30 degree family. Well, notice it goes at an angle like this in quadrant 1. It also goes at an angle like this in quadrant 2, in quadrant 3, and in quadrant 4. So those are all part of the 30 degree family. What's this angle in degrees?
180 is 30.
Right, because this is 30. This is 30 degrees here because this is 30 degrees. So this must be 180 minus 30 degrees, which is 150. The radians are a little tougher. Again, you can times by pi over 180 to find it. But you can also remember it. Pi over 6, okay? If I went to here, how many pi over 6s are there at pi? 6 of them, right?
Yeah.
But this is a little bit less. So what's a little bit less than 6 pi? A little bit less than, a little bit more than that. 5 pi over 6. Don't worry, you'll get these. Now the point, what's the point going to be?
135. Oh, degrees. Okay, that's normal.
Isn't it going to be the same numbers as this, except
X is negative.
the x is going to be negative?
Only the next week.
The next degree is 135. Once again, that's incorrect.
Doing the right side. Okay, that's fine. Plus 30, 180 plus 30. 210. I got that one.
Okay, so 210 degrees. What is that in radians? Oh my God, it's playing music. Stop it. There. Sorry? 7 pi over 6. Because remember, 6 pi over 6 is halfway around. So it's a little more than halfway around, 7 pi over 6. What's the point on the unit circle? Negative root 3 over 2. Negative 1/2. Good job, Sonia, answering that one correctly. What's this one?
330.
Whoop. What is it in, notice in radians, all the denominators for these ones are 6. So how many pi's over 6 is a complete circle, or 2 pi? 12, a little bit less. Yep. And what's the point? Well, it's the same values except the y is negative, right? Here we go. So that's the 30-degree family, or we call it the pi over 6 family. The next family. Is the 45-degree family, or the pi over 4 family. Okay? What would this angle be? 135. Because this is 45 degrees here, so 180 minus 45. What would that be as radians? What do you think? It's going to be 4. How many pi's are there in pi radians over 4? What pi over 4 is the same as pi? 4. 4 pi over 4. It's a little bit less. 3 pi over 4. What's the point? Same values as these ones, except the x is negative. This one. Well, if this is 180 and this is 45, what's this angle all the way to here? 225. How many pi over 4s do you think it is? 5 pi over 4. And it's the root 2 over 2's, but both of them are negative. And finally, 315 degrees, how many pi over 4s? How many pi over 4s are in 2 pi? 8 pi over 4, right? 8 pi over 4 is the same as 2 pi. So a little bit less. 7 pi. I did hear somebody say it. I just wanted to explain how I got it again. It's the same root 2 over 2s, except the y is negative. Okay. Finally, the 60-degree family, or the pi over 3 family. This one, how many degrees? 120. In radians, all the denominators are going to be 3. What do you think? 2 pi over 3. Because it's a little less than 3 pi over 3. It's half a circle. The numbers are the same, 1/2 or 2, it's the x is negative. Go down to the third quadrant, 240 degrees. How many pi's over 3? 4 pi over 3. And then the numbers are both negative, the 1/2 by root 3 over 2. And finally, this one, 300 degrees. How many pi over 3s? 5 pi. Because 6 pi over 3 is 2 pi, which is a complete circle. First one's positive, second one's negative. And that is the unit circle. Okay? So this is your equivalent of the 10 Commandments in trig. Frame it. Redo it in, like, I don't know, different colors if you want. The question is, how are you going to remember it? Well, look for patterns. First of all, besides 0, 90, 180, and 270, what are the denominators of all the points on the unit circle? What, 3? 2. They're all 2s. Okay? So that's something you can remember. Notice it goes for the radians, 6, 4, 3, 2. Okay? Notice for the x values, if there's root 3, did you want to go? Do you want to leave? You're being distracting. Thank you. Root, you're having a rough day. Root 3, root 2, root 1. It's 1. 1, 2, 3. That's another way to remember it. There's a song out there apparently, but I refuse to sing it. I don't even know what it is. Okay. There goes the talking. Told you couldn't last. But you said the rest of the period. You said, I'm not going to talk for the rest of the period.
And do you have it on tape?
Oh, no, I don't, because I paused it. Okay, so now you're just a liar. That's on tape. Okay. So, like I said, there's patterns to it. I don't recommend a certain pattern because I want you guys to come up with one that you remember. Okay? I don't want to try and force one on you. So, have a look at this for a couple of minutes, because then we're going to do the examples. And we're going to see if you can do any of them without actually looking at the unit circle. Just have a look at it. The main con, there's no reason to get excited. Look Look at your patterns.
I'm like, are the problems gonna be like more it's like this. It's like all of the they might be on like 50 or like
Mostly radiance. We're gonna get away from here. Does this mean you're ready?
Yes.
So, look, you guys. Like, if you can remember the first quadrant, that's a huge help. So remember, pi over 6, pi over 4, pi over 3. Okay? What's that? Okay, so this is 45 degrees, pi over 4. So what's the point on the unit circle? Root 2 over 2. Root 2 over 2. 60 degrees. That's the one up here. It's not, and think of it this way. You're going to go short on the x, long on the y. No, not pi. 1 over 2, root 3 over 2. Root 3 over 2 is longer than 1 over 2. It's bigger. So it's 1 over 2, root 3 over 2. Pi, halfway around the circle. Remember, don't just read them off your unit circle. Well, it's not helpful. I want people to try. Okay. Well, this is going to be a tough one. 5 pi over 6. Remember, the pi over 6s are the low ones. It's the ones that are closest to the x-axis. So the question is 5 pi over 6, where is it? Here, here, here.
No, 3.
It's in here. So what's this point? It's the long number, root 3 over 2, and then positive 1/2. Four pi over 3. The pi over 3s are the ones that are up high in the first quadrant. So it's going to be here, it's going to be here, it's going to be here. What quadrant? 3. So it's going to be down here. So it's the short value and then the long value. 1 over 2, root 3 over 2. But because it's quadrant 3, both negative. Ooh, this one. Negative pi over 6. Well, this is pi over 6. Wouldn't negative pi over 6 go to here? So what's that point? Long number, pi number? No. Root 3 over 2, negative 1/2. Seven pi over 4, those are the ones that come out in the middle. So here and here and here, 7 pi over 4, what quadrant?
3.
Quadrant 4, because it's almost a complete circle. So what's the point on the unit circle here?
2 negative root 2 over 2.
Right. Root 2 over 2, negative root 2 over 2. How about pi over 2? That's where we're just going right up here.
9. So then it's 1.
0, 1. 8 pi over 3. That's a bit of a tricky one because it goes more than a complete circle. Because remember, 6 pi over 3 is a complete circle. The 6 pi over 3 is 2 pi. So this is where we use our knowledge of coterminal angles, okay? So what I need to do is I need to minus the 2 pi to make an equivalent angle between 0 and 2 pi. Well, isn't that the same as 2 pi is the same as 6 pi over 3? Which gives me 2 pi over 3. That's an angle on the unit circle. 8 pi over 3 was too big. So where's 2 pi over 3? Remember the pi over 3s are the high ones? Which quadrant? Quadrant 2. So what's this? It's the small value and then the bigger value. Negative 1/2 because it's in quadrant 2, and then the 3 over 2. Yep. Yes. Yes, you can do that. Yeah. Negative pi over 5 pi over 4. You could change. You could add 2 pi and get a coterminal angle that's on the unit circle, or you can just think about going backwards. Remember the pi over 4s? Those are the ones that come out in the middle. So this would be negative pi over 4. This would be negative 3 pi over 4. This would be negative 5 pi over 4, which is what I'm looking for. So what's the point here?
Root 2 over 2, and then root 2 over 2.
Correct. And finally, 4 pi. Well, 4 pi is too big. That's 2 complete circles. Yep. But it's negative because we're going in the opposite direction. Like if you went this, if we went positive, this would be pi over 4, 3 pi over 4, 5 pi over 4. But because we're going negative, this is negative pi over 4, negative 3 pi over 4, negative 5 over 4. Does that make sense? Yeah. Finally, 4 pi. Well, that's too big. So take away a 2 pi. What do I get when I take away a 2 pi? That's on the unit circle. What points is that on the unit circle at 2 pi? 1, 0. Okay. And finally, just going the other way. This is a little easier. Answer in both degrees and radians. So 1/2 comma root 3 over 2. 60 degrees or pi over 3. Negative root 2 over 2, root 2 over 2. That's the 45-degree family, or the pi over 4s. What quadrant? 2. So 135. And how many pi's over 4? 3 pi over 4. One 0. 0 degrees, 360 degrees. 0 radians, and how many radians? And 360? 2 pi. See, you're getting it. Root 3 over, okay, so negative root 3 over 2, negative 1/2. That's the 30-degree family, because it's the reverse of the 60-degree family. In quadrant 3, so how much? 210. And this is the pi over 6 family. The question is, how many pi over 6s are in quadrant 3? 7. This is going back to the what degree family? 60. But what quadrant? 4. So for quadrant 4, we got to do 360 minus 60. And it's the pi over 3 family. Not 11 pi, that's way too big. Because 6 pi over 3 is 2 pi, that's a complete circle. So it's 5 pi over 3. That's all right, we get it. And 0, negative 1. 270 degrees, that's the pi over 2 family. 3 pi over 2. Okay. So a lot of what we did last year, except now we're adding the radians that you have to be familiar with. And don't worry, you'll get there.